So the next part we're going to do is skipped a couple pages there. They don't really apply to what we're doing here. Calculator stuff is we're going to try and find something given that tangent of theta is 3/2 and that the cosine of theta is less than 0. And we want to find the exact values, so not using a calculator, of sine of theta and secant of theta. Excuse me. So if we think about this, first off, if we're saying that cosine is less than 0, that means cosine is negative. And if the cosine is negative, but the tangent is positive, that means that the sine must also be negative. Because if the sine was positive, we'd be dividing a positive number by a negative number, and our tangent would be negative. So immediately we know that if we were looking at our unit circle here, we're at some angle over in this quadrant over here, quadrant 3, where both sine and cosine are negative. Both x and y values are negative. So we're somewhere over there. Now, how do we go about finding that exact value? Well, you might want to maybe try guessing and saying, well, I want to look at the main points, the square root of 3 over 2, the square root of 3 over 2, 1/2 point, the square root of 2 over 2, square root of 2 over 2 points here. Those are all negatives, by the way. And then also this over here, this one's the negative 1/2, negative square root of 3 over 2. And just start trying to find, if I do tangent of any of those, that I get 3/2. But you'll find that you don't. None of those work out. So remember, we don't have to actually use the unit circle to find this. What we can do is say it's true for any circle, but then draw a triangle inside any circle, and then just use the radius not equal to 1. So if we look at this, if I had a bigger circle, some other circle, and inside of it I drew a triangle starting here from the middle, right? This is not the unit circle, but I drew some other triangle in it like this, and I said that this was R, and then I said that this is going to be my y value, that's 3, and then that's 2, the x value, because remember, tangent is y over x, so we can just say that y is 3 and x is 2. This gives me a new right triangle I can look at. And so I'm going to go ahead and redraw it a little bigger and nicer so we can see this. I can draw a right triangle like this going down into that third quadrant. I'm going to, I didn't do this to scale very well. Let me try that one more time. Make this side longer. Like that. This is 3. No, this is 3, the y value. This is the x value is 2. And then we can actually use this and say, all right, this is going to be some angle theta here, and it's inside a larger circle. If that is the case, we can use the distance formula or the Pythagorean theorem here. 3 squared plus 2 squared has to equal our r squared, so our hypotenuse here is, or our radius here, is going to be the square root of 3 squared, 9, plus 2 squared, 4. So this is going to be square root of 13. That means that we can now have all three sides, and we can build our sine and cosine from it. So actually this would be -2 and -3. So sine of theta, remember, this is the opposite side, the -3, over the hypotenuse. So this is going to be -3 over the square root of 13. And there's our sine value. Now secant is 1 over cosine. And cosine is adjacent, right? Adjacent, let me get to these circles, is adjacent over hypotenuse. So instead of doing adjacent over hypotenuse, we're going to do the reciprocal of that. We're going to do hypotenuse, or r, over the -2, which is just negative square root of 13 over 2. Oh, and in this one, we don't want to leave that radical in the bottom. If we don't, you multiply top and bottom by square root of 13, and we get -3 root 13 over 13. And there are our two answers for that one. And again, I'm going to leave this next one for you to try. Basically build a triangle that has a side of 4 and a side of 5. Now it's negative this time, but cosine is positive, so think about what sine has to be, positive or negative. And then try to figure out which quadrant it is and which direction to draw your triangle in and what values are positive and negative. Use that distance formula and figure that one out. And again, I'll put this in the notes online so you can see it and check your answers. Last thing is reference angles. I'm not super interested in this part here, but the idea is that all reference angles have to be between, so reference angles they have to be between, angle, between, if it's in degrees, between 0 degrees and 90 degrees, and in radians, or between 0 radians and pi over 2 radians. So essentially what you're doing is looking for, back when we were talking about that unit circle, when I talked about how you could take and figure out just those first 3 points, just that first quadrant, and then figure out what the values were everywhere else. You're essentially kind of working that backwards. So you may have some angle, say, something that goes around like this. So first thing you want to do is find where it actually terminates. So maybe we have some angle that's doing something like this in a negative direction. It goes around pi, 2 pi times, and then comes over and like stops out here. And so you figure out this terminal angle right there. Well, what you want to essentially do is figure out, once you have your terminal point, you want to figure out what point in the first quadrant is going to have the same x and y coordinates, but maybe different by negative signs. All right, that's really what you're trying to do here. You're trying to just go around and figure this out. All right, so the first step is to figure out what the coterminal angle is. On this one, the coterminal angle would be something positive. We want a positive rotation for that coterminal angle. So it's going to be this angle right here. And then you're going to want to figure out, once you have that point and you look at the coordinates of it, whatever they happen to be, this would be a negative x and a y, you're going to essentially say, well, what angle in the first coordinate gives me the coordinates x and y? So I'm going to make them both positive and see where that takes me. Okay, that's the basic idea of finding that reference angle. So let's take a look over here. So let's find the reference angle for pi over 3. That one's pretty simple. It's pi over 3. It's going to be right here. It's already in that first quadrant, so it is just pi over 3. That's our reference angle. The next one is 3 pi over 4. So we go to pi over 4, 2 pi over 4, 3 pi over 4. We're right here. Well, this has those coordinates, and I kind of already did the reference angle as I counted it out, but essentially I'm looking at something that's square root of 2 over 2, square root of 2 over 2, and negatives for both of them. And so basically when I make that positive, that gives me square root of 2 over 2, square root of 2 over 2 for these coordinates, and that goes along with the angle pi over 4. All right, so the reference angle here is pi over 4. Last one here, or next to last one here, is 7 pi over 6. So you're doing pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So 7 pi over 6 actually ends up being somewhere over here. And it has coordinates, when you look at your unit circle, it's going to have the coordinates negative square root of 3 over 2, negative 1/2. And so what we want to do is go over to positive square root of 3 over 2, positive 1/2 right there. That gives us some coordinate over here like this. And the angle for that one is just going to be pi over 6. So our reference angle, what we refer back to try, basically what we refer back to get what the coordinates of it would be, we're kind of working backwards here, would be pi over 6. And again, I'll leave this last one for you, 5 pi over 3, but I'll put the answer in for you to be able to check it with. All right, that I think does it for this section.